Hello, and today we're going to be working on section 6.4, solving polynomial equations by graphing on a calculator. So our objective is obviously we're going to try and be doing our polynomial equations by graphing. So if you would get out your graphing calculator, and we're going to begin this. We're going to have two methods that we're going to work on to attack this method. The first method is going to be finding the intersection points of two different polynomial equations, and the second method is going to be solving and setting it equal to 0 and finding the zeros. Both of these will be the solutions, and we're going to demonstrate that we can get the solutions by these two different methods. So our first method that I'm going to have you do is I'm going to have go to your graphing calculator and put in this following equation. We have x cubed minus 2x plus 8, and so I'm going to have you take this first half of the equation and enter it into your calculator as y1. Then take the second half of the equation and put that into y2. So your equations are going to look something like this when you put these in. Now, just being aware, when you put in that minus 12x, make sure you use the minus sign down here and not the opposite sign, because those two different pieces are going to be very, very strategic. Once you've put these two equations in, just so we're all on the same page, we're going to go to Zoom and Format, and I'd like you to turn your grid on in this case, which means you're going to go down to the third line and go over to Grid Dot and hit Enter. And then you're going to go down to your grid color and pick whatever you wish. Then we're going to set our window. Our window for this, we're going to have a standard window, so go to Zoom and then click 6. Now we're going to graph this on a 10 by 10 window. Now I know this is not perfectly square, but it does give us the basic two graphs, and we can see where the blue cubic function crosses the red line. Now we want to find the intersection points of these different coordinates. So we're going to go second calc, we're going to choose intersect, and we're going to arrow as close as we can to the farthest point on the left. And that's our x value is going to appear just momentarily. Right now we're down at -6. So we need to get our x value a little bit closer. And there it is. So now we're going to hit enter 3 times. 1, 2, 3. And it's going to give us our x value of -4. So our first value is x equals -4. Now let's find our second value. Second calc, intersect. I'm going to choose to go up and down on the red line by hitting the down arrow, and it's going to shift me to the red line so I can a little bit easier see my spot. Now, when you're working on this, you need to get to a point where you're somewhat close to that next intersection point, at least halfway. Now hit enter 3 times. Find the intersection point. This is x equals 1. Now I don't really care what the y value is on this because I'm just concerning about my next one. So x equals 1. Now I'm going to go back to my third equation, and I'm going to arrow with second calc, intersect. And right now I'm on the blue line, so because the blue line is all within vision, I can just move over on the blue line. I'm relatively close now, so I'm going to hit enter 3 times. And my third value is x equals 3. So there are my 3 values, x equals -4, x equals 1, and x equals -3. So if we write this with solution set notation, x is an element of the set of numbers -4, +1, and +3. Sorry that I wrote a -3 there. That was incorrect. So that's the first method that we're going to use. Now, the second method we're going to use is doing the exact same equation, but now taking this problem and setting it equal to 0. So if we take this problem and set it equal to 0, we're going to have to bring that x over. So we're going to get x cubed minus 12x plus 8 minus x plus 4 equals 0. Combining like terms, x cubed minus 13x plus 12 equals 0. So in our value of y1, we're going to put in y1 equals x cubed minus 13x plus 12. And this is the equation we're going to put in. So let's do that now. Y equals x cubed minus 13x plus 12. So go back to your y equals. We'll clear out these. And we'll put in x cubed minus 13x plus 12. Just checking to make sure we have that correct. We do. And now we're going to graph this. Zoom 6. And now we're not looking for the intersection of two lines, but we're merely looking for where this cubic function crosses the x-axis. And so now we're going to go to second calc, and we're not going to find the intersection, but we're going to find the zeros. Right now you can see at the bottom of the screen the x value is at 0 and the y value is at 12. So it's really off the screen. And so I'm going to arrow to the left until my x value gets close to what I think it's going to be. And here you're going to see it appear in just a second. And there it is. And so we need to get left of the x-axis intercept. And so I need to go a little bit below that and then hit enter. And you'll notice a little line appears with an arrow. And then I'm going to go a little bit to the right of it, hit enter again. And we need to make sure that our intersection point is in between the two arrows. And if it is, hit enter a third time. And see, once again, you get the value, x equals -4. Now we're going to do this again just to practice. Second calc, 0. And now I need to move my cursor so it's going to be over somewhat close to the x value of 1. I do know that that's already the answer, but nonetheless, we're going to watch the values at the bottom of the x values down here where it says left bound. And as it starts to get close to 1, you're going to see that cursor appear. Now this time, the little x spider is above the x-intercept, and that's because it needs to be to the left. And so I hit enter, and my little line appears with my arrow. I go a little bit to the right of it, hit enter a second time, guaranteeing that my intersection point is in between my arrows. I hit enter a third time, and once again I get x equals 1. Doing this one more time, second calc, 0. Now I'm going to move a little bit to the right. That's certainly close enough. I'm going to move past the third intersection point with 0, hit enter. And once again, my x-intercept is in between my two arrows. I hit enter a third time. And once again, I get the same answer in 3 different times. And so my solution set, once again, will be x is an element of the set of numbers, -4, +1, and 3. So these are two different methods to use when we're solving an equation using our graphing calculators. Let's practice one more problem. Here we're going to consider the equation 2x cubed plus 5x equals 7x. And with this problem, our left-hand side of the equation is going to be the left-hand side, and that's going to go into y1, and our right-hand side into 7x. So let's put those equations in to our y equals function. We're going to have 2x cubed plus 5x squared on the one side. On the other equation, we're just going to have 7x. So now we're going to take a look at this by Zoom 6 to get a basic feel of what the problem looks like. We have a cubic, and then we have a very vertical line. Now, you have to extrapolate some data here and assume that that vertical red line is probably going to intersect the blue line. But if you weren't sure, you could go to your window, and you could go down to your window of y min, and you could change your y min, say instead of -10 to -30. And then you could look at that graph there, and now we can guarantee. Now notice all those dots are coming from my graph dots. Those could get a little distracting if you're not careful, but now you can see the 3 intersection points. So we're going to go and we're going to find these 3 intersection points. Second calc, 5 for intersect. I'm going to go to the left to get at least halfway towards that graph. And very quickly I did. I'm going to hit enter 3 times. And my first value, C, is negative 3.5. So x equals negative 3.5. Going back to my graph, second calc, intersect. I need to get at least halfway there. Hit enter 3 times. X equals 0. And my third point, intersect again. Get at least halfway close to that point, which I am. Hit enter 3 times. And my third value is x equals 1. So my 3 values for this is x equals negative 3.5, x equals 0, and x equals 1. And written in set notation, x is an element of the set of numbers negative 3.5, comma 0, comma 1. Let's take a look at this exact same problem, but now let's set it equal to 0 and solve that way. Setting this equal to 0, 2x cubed plus 5x squared minus 7x. Now we're going to set that equal to 0, and that's going to be our y1. So 2x cubed plus 5x squared minus 7x. So now instead of finding the intersection, we're going to find where it equals 0. So I'm going to go back to my y equals. In my first equation, all I'm going to do at the back end of it is I'm going to add on a minus 7x, and I'm going to delete my other equation. So now when I graph this and I look at it just very quickly, I've still got that big zone all the way down to negative 30. That doesn't really matter anymore. And you'll notice the graph goes above the value of 10. And so I'm going to go back to a zoom 6, which is my normal values, to get a good idea of what it looks like within my bracket. I'm only concerned now with the 3 values where it crosses the x-axis. And so I'm going to go second calc. Now I'm going to go 0. My spider right now is at x equals 0, and so I need to move that all the way to the left. And so it's going to appear again. Here it is. Oh, I went past it. There it is on the left. Arrow a little bit to the right. There it is. Now surrounding, hit enter a third time, and you get x equals negative 3.5. So what you can see here is as you're working through these, some people prefer the intersection method. Some people prefer to have the 0 method, but it's good to be able to do both of them as we're working through these. And as I would go through, you're just doing the same process, a left bound, a right bound, and then entering a third time. And in both cases, you're going to get the same answers. And so my point being here is, as you're working through these, it doesn't matter which method you use, so long as you're comfortable with both methods, either using the intersection method and breaking it into 2 equations, or the 0 method on your calculator. This is another example that's shown in the book that I wanted to give a hint to. And notice with the 3 solutions they have at the bottom, they plug them both back into the equations, and in all 3 cases, the solutions checked. That being said, we have a short assignment tonight, 1 through 9 odds, so we're just going to be working about the odds. If you wanted additional practice, you could do the evens, but I think the odds will give you enough practice to work through this. Have a great day.